we are going to look at a couple example problems using implicit differentiation. And this one says find the second derivative of y with respect to x. So that means we've got to differentiate twice. And so we have our first derivative with respect to x of this, of x squared plus y squared equals the derivative with respect to x of 25. And so 2x, remember that's the derivative with respect to x, plus 2y dy dx equals derivative with respect to x of 25, which is 0. We solve this for dy dx, and we get negative x over y. And then we do the derivative again. So we take the derivative of the derivative with respect to x of dy dx. And so this is equal to, well, we apply the derivative to this side. So the derivative of negative x, the quotient rule, is negative 1 times the bottom, which is y, minus the top, which is negative x, times the derivative of the bottom, which is dy dx, all over the bottom y squared. Well, this looks messy, but over here I have the second derivative of y with respect to x equals, negative y plus x times dy dx. Well, dy dx is negative x over y times negative x over y, all over y squared. And now this is equal to, we have negative y plus x squared plus a negative x squared all over y, or that's over y, all over y squared. Well, this is equal to negative y minus x squared over y times 1 over y squared, which gets us 1 over y minus x squared over y squared. If we make this a common denominator, then that gets us y squared, negative y squared minus x squared all over y squared. Well, we can pull out that negative, and we have negative y squared plus x squared all over y squared. Well, y squared plus x squared is 25, so this is equal to negative 25 over y squared. Okay? Now, technically, I suppose you could have been done here, but noticing that you do have that x squared plus y squared and can make a substitution is a nice thing to do. Now, the other derivative I want to look at is just the first derivative. So find the derivative of this thing with respect to x. So we're going to go ahead and chain rule that. So the derivative of sine is cosine. And then we have xy. And then we have this inner function. So we've got to do product rule times the derivative of the first, which is x, times the second, which is y. The derivative of x is 1 times y is y, plus the first, x, times the derivative of the second, dy dx, equals, we've got to do the derivative of that side. The derivative of this side is 1, because the derivative of 7 is 0, the derivative of x is 1. So now this is equal to cosine xy times y plus x cosine xy dy dx equals 1. So now we're going to go ahead and subtract off this cosine xy times y. So we have x cosine xy dy dx equals 1 minus cosine xy times y. And then we can divide off x cosine xy. So dy dx is equal to 1 minus cosine xy times y divided by x times cosine xy. And it is probably worth writing this as equal to 1 over x. 1 over cosine is, of course, secant minus, and then I have cosine xy over cosine xy, but y over x, so minus y over x. And that is dy dx.